Today's video is going to be about logic games. But before I get there, I want to take a minute to talk about how weird this channel is. This channel has always been kind of a haven for my obsessions. So that means computer games, programming, computer hardware, logic, accounting. It's one of the reasons I don't have a Patreon is I like to be able to make videos about whatever I want to do. Sometimes those obsessions intersect, and I get to make a video about more than one of those. That happened in the summer of 2022 when I did a brief series about Joachim Breitner's The Incredible Proof Machine, which is a sort of gamified proof assistant meant to be used in concert with a class to teach students introductory propositional logic. Well, someone asked about that game on Twitter the other day, and in the process of looking for it, they pointed out that there are some other systems kind of very much like this. And one of them I thought was pretty interesting, and so that's what we're going to be looking at today. This system is called QED. It describes itself as an interactive textbook. The URL, I'll put that on screen right now so you can find it yourself, or you should be able to search for it with no problem. Some interesting things about the landing page here. One, this was originally written by Terence. That's a little bit intimidating because it means that I'm using an app written by one of the most famous mathematicians alive today, which means that the price of me getting things wrong is humiliating myself in front of the entire world. So I will begin by observing what I always observe whenever I do any kind of instructional video, which is that mistakes are how we learn. And hopefully you've bought that enough that it won't be quite so embarrassing when I inevitably make all these mistakes. The other thing that is kind of neat is they point to a number of other systems that are similar to this, a number of other games that are similar to this. The Incredible Proof Machine is on here. I want to call out two of the things on this list as specifically relevant to this channel. One is Within Proof, which is a 1960s, I believe, era physical kind of board game. It's a dice game meant to teach very young children, like around 6 years old, the basics of what a well-formed statement looks like in a logic system. I've never used Within Proof. One of my friends actually just got a copy, but maybe someday there'll be a video on it. The other is this Tarski's World. Tarski's World was a software product that came with a book written by, I believe, a couple of professors at Stanford. I'm embarrassed. I don't recall their name offhand. I'll look it up and maybe put it in the video down below as a caption. I never used Tarski's World, which also taught symbolic logic. I, however, in my data structures class back at CMU, used a similar but different product called Turing's World that was all about Turing machines. And it's on my list of videos I intend to do a kind of walkthrough of Turing's World sometime. So you have that to look forward to. All right, so we begin by disclosing the sections and exercises, which shows you everything we've got in the book. And you could see it's kind of a walkthrough of symbolic logic or propositional logic. We're going to start with 1.1, Conjunction Introduction. Now, I found the UI here to be a little opaque. I have not gone through the course completely. I did basically sections 1.1 and 1.2 before coming to do this video. And I had to click around a bit, so hopefully my mistakes will teach you. What we get here, section 1 and an exercise. Given A, B, and C, deduce A and B and C. They tell you what the shortest proof is. And so here's where your sort of work area is. So we've got these things in the root environment, which are our propositions, and we want to make this proposition or this statement up here. So what you're going to do is you're going to drag these statements around, and if you drag them on top of each other, if you drop them on top of each other, then we get some introductions here. So we have a conjunction introduction. I believe that's an axiom, right? What happens if I click on it? We get brought to Wikipedia. Well, it's a rule, I guess, more properly. Okay, so we have two possible deductions from A and B right now. We're going to take A and B. And by doing that, we now have a new proposition in the, I think of it as the work area. They're referring to it as the root environment, A and B. So we're going to take the statement A and B, or the proposition A and B, and drop it on C. And you can see that our available deductions changed, and A and B and C is in fact what we're going for. So the thing I like about this is as you are taking these steps, your proof is written along with what your rationale in brackets as to why that step is valid. So we're going to click this last button here. We got a pop-up, and they add turns green, very satisfying for something to turn from yellow to green. And they add our last statement here, and they add a QED with a happy little exclamation point. I love that. We have some controls here to edit the state of the proof. Next exercise. We're going to click on next exercise. They're telling us here that it is permissible to drag a statement onto itself. We need to know that in order to do this task, which is given A, deduce A and A. All right, so we're just going to drag this onto itself. We have two different ways to say A and A. I'm going to be a rebel and choose the second one. 3 lines, that is the shortest proof. I will say in this video, I am in no way going to be trying for efficiency or records or anything like that. All right, so that, I believe, concludes the conjunction introduction exercises. So instead of doing next exercise, we can just scroll up to the top here. So now we're going to get to conjunction elimination. So for the record, I'm not going to go through all of these exercises. For one, the fun for you is doing these things yourself. I just want to go through these enough that you get the idea. And then I'll have a few things to say about, and this is where I'm going to get into trouble potentially, about how it feels to me as a layperson. We'll put it that way. We're going to prove that and is commutative. The other thing I've actually thought of doing here, I think I did the first sort of some simple exercises from the Software Foundations course, which used Cook. And what might be fun is actually to do some of these exercises in a non-visual proof assistant, such as Lean. If that would be something that interests you, please leave a message down in the comments. Okay, given A and B, deduce B and A. So we do not have our isolated A and B propositions here. In this case, we don't have to drag. As soon as we click on A and B, we've got 3 possible deductions. We've got idempotency, we've got conjunction elimination, and 2 flavors of that. So obviously we want to eliminate, we want to do 2 different conjunction eliminations. Oh, and I clicked on the wrong thing. Okay, I don't have to re-click on it. I can just do that. And now I can drag B onto A. Actually, it doesn't matter which I drag because I will be given both of the introduction deductions. We're going to click on that, and there we go. Thus it is shown. All right, let's go through. How far do we want to go? I think we will go to the end of 3.1b. Obviously, there's a lot more here, but I don't want to hammer home the point unnecessarily. So we'll go to the next exercise. We're going to prove that and is left associative. Given A and B and C, deduce A and B and C. Do you like how I kind of indicate what we're proving just by voice? It's a talent I have. Okay, we're going to do a few different eliminations here. Okay, we're going to do a third elimination. Oops, I did the wrong one. We need both of these, don't we? Okay, and now that we have this, we can B and C, A and B and C. So obviously this is a fairly trivial proof. I have two thoughts about this that occurred to me while I was just messing around with it. And I cannot say which of these is better or worse from what's the word? I always think the word is didactic. Pedagogical. I'm going to say it's pedagogical. I don't know which of these is better from a pedagogical standpoint. So one thing that QED gives the learner, gives the student, that the incredible proof machine does not, is this proof state in written form. If you're going to be doing proofs as more than just a game, you want to know how to create these proofs and have them be something that another mathematician can read. You're not going to typically share your proofs, as in the incredible proof machine, as state diagrams, right? So that seems to me like a mathematician would appreciate the fact that manipulating this graphically yields you a text proof. One thing that the incredible proof machine gives you that this does not, or that I haven't found if you can do it in this, is the ability to work from both ends. One of my favorite cheat sheets in math is a professor named James Aspneys, who has a set of notes on discrete mathematics, which are basically, this is the minimum amount of stuff you need to know enough mathematics to do computer science. And he has a section on proof. One of the things he says, which when I originally read it, I assumed it was a joke, and after reading it more, I don't think it is one proof technique that he likes when you could use it is work from both ends. Start at the beginning of the proof and work forward. Also start at the end of the proof and work backwards. And when you meet in the middle, change directions and pretend you were only working forwards. Maybe QED does allow this, but I haven't yet found a way to do it. All right, so next exercise. Given this is right associativity, so this is basically a similar thing to what we just did. I'm going to eliminate some conjunctions. And I need A and B and C. There we go. All right, so now I believe that we're on to disjunction introduction. So this one I wanted to get to because disjunction introduction and elimination in the incredible proof machine was one of the weaker UIs, I thought. I had to stare at it for a long time before I understood what exactly it was implying. Now, I want to be really clear. Everything I say in here that is even a little bit critical, I'm just some dude on YouTube, right? For the case of the incredible proof machine, I know for a fact that that was used as a tool, as an adjunct for a class, and I was not taking that class. So anytime I say something like, ooh, this didn't seem that good, it's me, not the tool, right? I'm using these things in a different context, just dorking around with them a little bit online. Please, I don't want anyone to view anything I'm saying as any kind of I could do it better or as a criticism of whoever wrote the tool or wrote the game. But that being said, disjunction introduction and in particular elimination, I think I remember finding a little bit confusing in terms of how to use it. Some deductive rules use formulas known as well-formed formulas. There's that Whiffen proof reference. They look the same as statements. A formula could be either true or false. So that's why they're in this separate window here. A is given, that's true. B and C, they're formulas, but they're not necessarily true. So we're going to be able to introduce a disjunction or to use one of these laws, drag a formula from the formulas window to a sentence in the root environment or vice versa. To apply this to future exercises, one needs to select 3 hypotheses A, formula B, and formula. Control click the third. All right, so this is a little bit... Okay, well, let's try it. So we want C or A or B. So A or B is on the inside. So I'm going to not follow the instructions. I want to see what happens if I drag this onto another formula. It tells me it won't work. Okay, that's good. So we're going to drag from formulas onto root. We get disjunction introduction, A or B. That's very straightforward. Drag C there, C or A or B, QED. All right. Given A, deduce A or A. Okay. I see. So if we dragged A onto itself, that gesture is going to always provide us with a conjunction introduction. But if we're dragging from the formula onto the root, or vice versa, I think we can go the other way, they said, we're getting the disjunction. Nice. I know I said I'd stop. Let's do one more. Let's do assumption. Given the formula A, deduce A and A, assuming A. I see, we've been given a formula here, not a statement. Formulas, this is weird. Formula is just, normally a formula would be something that you introduce, right? And so having the separate formula box is a way for them to provide you something in the UI to hang on to so that you could introduce something new without having to type it. I think in the Incredible Proof Machine, there was this conditional block that you would always drag on when you wanted to do that. So I'm betting that if we just drag it to the root environment, that allows us to introduce an implication. A, assuming A, and here I assume we can drop it onto itself, A and A, assuming A in the brackets. Great. Do we keep going? What do you say? Let's see what the next one is. All right, really, this is going to be the last one, then I'm stopping. Given formula A, B, and C, deduce A and B or C, assuming A and B or C. Okay, so this tutorial is teaching us, I think, how to, just that if we introduce an assumption or assumptions, everything's going to hang off of that assumption. That's what I think is going on here. Oh, so it wants us also, right, so, I'm not sure. Okay, so I can, now it's allowing us, it wasn't doing this before. I guess this is unlocked by this exercise. Now I can assume an A. So I've got that, A and B or C. That's over there. Now I've assumed it. And now I should be able to just drag it over, right? I want to introduce the implication. It was that simple. I got stuck reading this and getting confused. Well, that's about as far as I want to take us today. I don't think it is a lot of value for you, for me to go through all of these and use my broken brain to show you my bad logic. I do intend to go through these, but I'm going to do it without the pressure of being on camera. If you're absolutely desperate to see me slog through these one at a time and make tons of errors, feel free to leave a comment. I'm inclined to not do that, and instead to let you have the fun of using QED itself by yourself. I think it's an interesting way to approach symbolic logic, propositional logic, and I encourage you to do so. I will put the URL on screen one more time. I will also put it in the notes. I hope also that by my remarks at the beginning, I've given you a taste of some of the other gamified systems that I hope to have time to look at in the coming weeks. This has been Programming Like It's 1979. Thanks for watching.